They've got a bit of a presentation just around the ADAS system on the vehicle in the background there. So over to you, boys.
Thank you, Jason, and welcome everybody. Again, some of you who are joining us in the morning. I'm guest here also in Blenheim. So our host today is Tony Richards. So I'll pass that to Tony. So Tony, what do you have here for us?
Afternoon, everyone. Thanks for your attendance. So behind me here today, we've got a common example of a car that's been involved in a collision. Bit of a backstory on the event. The owner of the vehicle was on his way to the airport with the in-laws in the vehicle, and the City Smart Brake support activated at the time. It was about 5k away from his home, 6 a.m. in the morning, and there was a black car in the left-hand lane, completely black, no white spot, no nothing, black. So he took the evasive action of turning to the left-hand side, favouring the culvert rather than the oncoming traffic. As a result of that, you can now see the outcome here. So,
all right. So it doesn't look like it's ready for the calibration. I can say that. But maybe because this is about ADAS made easy, and our document that we will share, it's identifying the sensors. So maybe we should first go with the visual check, very short one, not 47 points. How we're doing it. But let's see what kind of sensor this vehicle has. So Tony, can you please show us, point to some sensor that you can identify there? All right, so we have a LiDAR sensor on the windscreen. We also have a camera sensor on the windscreen there. We also have a long-range radar on a front, behind the front badge. He's checking for the blind spot monitoring indicator. We have it. Yeah. We have a blind spot monitor indicator, which will point to the blind spot. And reverse camera. So we have a reverse camera there. So there's quite a few ADAS systems and ADAS sensors on this one. So if you are, we have also potentially adaptive headlights. Is there any question maybe for the moment, or?
No questions yet, mate. So please press on.
All right. So if you are in insurance business, if you're making assessments on a picture, you probably will miss a few things. So what we will show, what will be the next step in a collision diagnostic. So I'll share the screen, and we have the vehicle connected with our equipment, with our scanner, and just a second. I think I pressed the wrong button. On. All right. Let's see how we live.
No, we haven't got your. Here we go. We're there.
There was a little bit delayed. All right. So this is the list, and let's go through the list and see, what we have. So we can see definitely adaptive cruise control. That will be our, front radar, Mazda radar cruise control. We see some faults, and let's go slowly through that and kind of make very fast assessments. We also see that blind spot module is here on the list, some faults inside, and then we go into the list.
I'm just going to interrupt you, Igor. I just noticed up the top there that we the airbag computer has a green tick on the left-hand side, or the SRS module. Restraint control module. That would sort of tend to indicate that there's no fault codes in the airbag system, which to me, I would expect in an impact you might see airbag deployment, and normally that would log a fault code in the restraint system. So can you just confirm, obviously, that the airbags are not deployed?
We have airbags out or no?
No, there's no lights on the dash either.
Okay, so there is no light on the dash for the airbag, and the airbags are not deployed in this accident. So
right.
Let's go. No, that's good notice, Jason. Thank you. So what else we have? We have the distance control smart city brake. That will be a mid-range LiDAR sensor here, which we identify on the screen. And then we also see front camera here, so that's also identified. And we're confirming that we have headlight adjustment here, another small system. So let's go very fast all the way to the bottom.
Yeah, I think another thing we've noticed there, Igor, is all the red dots in every particular module. So red indicating to us that there's a hard fault code or a present fault code that's logged, and the yellow generally means it's a history file code. But looking at all the red ones, they all seem to point towards control module. Oh, there we go. That's right. That the ABS control module is not communicating or lost communication. They're all U codes, which are body codes. And down the bottom there, I see that there's a big red X next to the ABS module, which is, to me, straight away, I'd probably, looking at that, you'd expect that maybe there's been damage or an interruption to the power supply to the ABS module, which looks like it could be where it's probably taken a bit of a hit on the right-hand front there. So straight away, we'd look at that, and you just probably want to investigate that a little bit further to understand a bit more about why that's not communicating.
Yeah. I mean, great notice, so we have on top of our, visual check, we have additionally ABS module to check. So it can be, like you said, something small, something big, I assume will be big value in this vehicle. Maybe wouldn't be written off just because of that fact, but you never know. It can happen. Any question at the moment? Are we moving with the questions, or should we, maybe introduce a little bit more?
Just keep on with your introduction. We've got no questions as yet. So yeah, carry on, gentlemen.
All right. So let's maybe go in one particular system, and then see what kind of data actually we can look at there. And I'll just reconnect here.
So just to explain a little bit further, so Igor is connected to the Mazda through Bluetooth communication to our Texa diagnostic tool. So what you're seeing on the screen is our that's the diagnostic equipment we use, so we can go through and interrogate modules and look at live data and obviously extract fault code information. So sorry, Igor, carry on.
All right. Yeah, this is the software layer for the Texa. There are many different options on the market, So we're using at the moment the second biggest European company, and this is our tools. So I selected the distance control smart city brake support module, which was that LiDAR, which Tony pointed out. And we can see here in parameters, only few values. We can see the voltage is stable on 12.9. But what is interesting is to see the distance from the bumper to the target, which is the value detected by the sensor. So in this moment, the LiDAR sensor, obviously the glass was not having any impact in this accident. And its value is jumping in between the 15 and 4. On this green, we can see this is the minimum value of 4.25. I can confirm it's actually dropping in between 275 to the 15. So what's happening, if you can see on the other camera there, maybe you can look at the movement of the Tony. So if the Tony moving across the center line of the vehicle, he will be picked up as an object, and then in one moment he wouldn't be picked up. So if he's standing on that side, can you just be still and maybe just in the focus there? Yeah. So he's on a distance of 2.75 meter, and we have a tape meter on the floor, and he's actually around 4 meters from that sensor there. LiDARs are not, depending on generation, not that accurate. But what we would like to see, what is the field of view? Because that's something which also you wouldn't have in lots of OEM manuals. And that can help us understand, why this accident was happened. So, Tony, if you can move, in that line toward the vehicle, just that we see maybe movement. And can you please stop somewhere there? And can you move from the center line maybe one step back, yeah? So he's already lost from the view. Maybe he's back in line, and then maybe forward on the other side, and he's again lost. So that gives us the idea that we have a very narrow field of view, which is expectation for the older generation of that sensor. So we just want to introduce a few of these terms to you. Maybe we can I'll stop sharing here, and maybe we can go back on a story how actually accident happened, and maybe introduce a little bit of the client expectations, and see, is there something more to talk about here? Any questions, Jason?
Still no burning questions, so yeah, please carry on.
Don't be shy, guys. Don't be shy. We're ready. So on the side of accident, one thing was interesting. He said, Tony mentioned 6 a.m, blackout. Yep. So these are very challenging conditions for the camera here. We can also go later and see maybe angles. And I think one of the questions which came earlier was influence of the aftermarket glass. So very challenging condition in the morning for the camera. But yeah, can you check the glass, please? Is it so? What we will do, additional check, like if the glass is OEM or aftermarket. Aftermarket. So Tony confirmed there is a market there for the aftermarket glass. That's something which we will add on in our process just to understand, better the whole thing. So we have 3 sensors, and obviously airbags didn't deploy. We cannot. What does that mean? We cannot go back with the event data recorder and extract the data because the accident was actually not recorded. So that's another challenge for the guys who are forensic and crash investigators in this particular case. But that doesn't mean that we cannot generate some data and try to understand why this accident happened, because the government road to zero is designed that we don't have any deadly or serious injuries from the accident like that, which was in this case. So back on a sensor side, very narrow field of view for the LiDAR, long range radar, which we can investigate. It's still present. It's not smashed completely to be damaged. And then that camera, which was having this challenging condition in the morning. I mean, you will fairly expect, as a driver, that when you're driving the car on adaptive cruise control, that you have, because everybody talking these days about autonomous emergency braking, that you maybe have that kind of feature on that car. This one is a bit older, so maybe it doesn't have it. So accessing the additional OEM information, we can confirm, do we have here autonomous emergency braking? And in any case, that LiDAR didn't respond fast enough. And we understand, from the distance where the cow was from that narrow field of view, that actually was not possible. The system will perform actually very well. It will definitely underperform from the expectation of the client, of the owner. And from my understanding, Tony, the client was purchased vehicle purposely because of the ADAS. Can you share that because I think it's important for the...
Well, this particular client travels in a metro area for the majority of the use of the vehicle. So they're using that city smart braking regularly. And I think their expectations of it was different out in the countryside than what it was in the city. And one of the other things I do is we're talking about sensor fusion here in between the radar and the LiDAR. And what we know now is that there was potential for there to be a weak link in those two with the LiDAR. As you guys may have noticed, when I stepped closer to the monitor, it stopped reading at about 4.5 meters and went straight to 15 meters, which is its default.
Yes, correct. Well, definitely the system didn't perform as the client expected, and that's the challenge. And what we can say, 80% of New Zealand roads are actually the rural roads, and some of the systems are designed when we're talking about pedestrian detection and cyclists and all of that, it's designed more for that urban area, which is for us 20%. I would like to see, or maybe make it on the joke side, the software, which is including our wandering cattle around, because that will help our agenda road to zero. Because if we have cases like this, even the latest car with the autonomous emergency braking and pedestrian detection still potentially wouldn't perform the braking on just detecting. It wouldn't identify the cow, and it wouldn't perform wouldn't in that sensor fusion wouldn't provide the information that actually the braking needs to kick in, and you need to have that braking there. There is terrible accident from 2017 on the truck side in Europe when they investigate. The truck was hit another truck which was towing in a trailer bulldozer, and in that moment, Volvo later investigated a similar vehicle. Radar was picking up detecting the object in the front, but the camera side didn't actually identify object, because in that moment you wouldn't believe, but bulldozer on a trailer was not common picture in the traffic, was not programmed in. So achieving that road to zero will be very hard from absolute position. So we actually recently came to the different terms. So maybe Tony, you can tell more how we see that, how this can be achieved.
Well, I think we need to take a standpoint of more informative safety with more explanation as to what the system is capable of doing on those particular vehicles at the time that they're being purchased. And currently there's a lack of that information and an over-expectation that the vehicle is going to be able to react a lot better than it can.
Yeah, so, I think you're really right there, Tony. It's a really good point that when the vehicles are purchased and someone's going out buying a car that they think is really, really safe. And I think one of the worst words people use in a sales pitch is autonomous or autonomy. And the expectation of the client, what the vehicle can do for them versus the reality of what it can actually do is probably two different things. And it's a big thing around awareness. I think they're very, very correct on that. Sorry to interrupt, but yeah, I think that's a massive thing, is awareness of the systems, how they operate, what they can do, and what their limitations probably are.
I mean, even myself, I got into a vehicle the other day, and on the steering wheel it had ProPilot, and then it had another button with Autopilot. And I was like, okay, so what's the difference between those two? What does this vehicle actually do differently? And does one mean that I don't have to touch the steering wheel? And literally, that's what it might lead some consumers to believe.
Just got a good question here from Todd. Wouldn't most AEB systems pick up a cow? Is it likely to be an original calibration issue, or maybe due to the narrow field of view? And I think we did sort of touch slightly on that, the word sensor fusion we use, where there's multiple modules at play. In this case, looking forward in this vehicle, there's LiDAR, there's radar, and there's also camera. And with sensor fusion, the important thing is for it to make a decision, it's got to obviously interpret all of that information in the split second and then make a decision based on the three inputs, and depending on the programming and depending how they've programmed that vehicle, as to how it might react and which it might lay more preference to, or may the information which might carry more weight in that instance. But I don't know if you want to elaborate on that a bit more, Igor?
Well, yeah, I absolutely agree with you, and it's a good question, because that kind of three level of the sensor fusion, they call it high, medium, and low. On a high level, you'll expect something very high technological. It's actually very opposite. It's actually is the worst case. So, which means each sensor calculating everything for himself, and then he kind of say, okay, I didn't identify nothing here, or another one said I detect something here, and that decision will be made either one of these. And that kind of problem can be if decision will be made on the side of the camera, and camera didn't identify that. And I think the question was if the cows should be actually part of the software. Actually, they are not, because that's just how it is. And on a lot of them, because the development of all of that is very expensive, and technology, it's going fast but it's also very expensive. So the producer tried to put cheaper options in a lower low range vehicles. And on the just the AAA, 3 days ago, we'll share that, soon. The AAA in USA actually made another research, third one in a row, where actually systems, autonomous emergency braking systems, still have a problem to detecting pedestrians and to detecting, the cyclists. They still not even yet with the pedestrians in, and then, we from New Zealand, we will send a request, hey, Mazda, put us, the cows in, because we don't want to genetically modify our cows to be white, or something like that. I mean,
yeah, so well explained, I suppose, and there's limitations around those particular idiosyncrasies and weird things. So yeah, there's certainly a lot at play, I suppose. Another question from James is: are we looking to ascertain faults with the crash, or obviously lay blame on where the crash happened, or are we looking to reset everything after a crash? And I suppose for us, in the first instance, it's more about understanding what's been damaged in this case, and what may need to be repaired, I suppose, or that may need calibration afterwards, or when the collision diagnosis process, so the collision repair industry can obviously quote this vehicle right and make sure we return it back to its previous state. So Tony probably can elaborate a bit more on that too, I would imagine.
Yeah, as far as an estimated current position is is they're focused on digital images, and collision diagnostics is something that's extremely important because you obviously can't see the condition of the electronics without getting in, diving down, seeing whether or not that LiDAR is also going to have to be a contributing cost to either the client or to the insurance company to put that vehicle back on the road with the sensor fusion, the calibration to be done correctly. So on this particular vehicle, there is a multiple factor of what needs to be addressed more in the correct repair process. And the problem that we see in the industry, and I've been a collision repairer for many years now, is that having the access to that information easily, readily, VIN specific, to be able to carry out that repair properly is challenging. It's very challenging. So we're navigating our way around that, but it's not something that is widely accepted as a repair process in the industry at the moment. And I look forward to that day that it is, so we can actually put everything back on the road as it was designed to operate.
Yeah, and I think, Tony, we're obviously in our infancy of understanding the background and the whole big picture. So probably one of the big challenges for us is to clearly identify these problems at the point of quoting, and then, like you say, that pathway through the repair, through to the obviously the vehicle's finished, its components been replaced. Potentially, they might need coding to the vehicle if you had to replace VIN specific modules, and then there's a recalibration to be done. And again, understanding that there's sensor fusion, that there's other things at play, not just the one. Obviously, in this case, you'd look at it and you would assume from an image that, the radar's probably been impacted, or the front bumper's definitely taken a significant impact. So we would look at calibrating that front radar, but now just obviously understanding about the LiDAR and the camera's importance and the role of identifying that, or identifying different images or different objects, there's an argument that we would probably need to look at calibrating not just the radar, but the LiDAR and camera, because there's an assumption that we can't make, and that is that before the vehicle had the impact, that the LiDAR and the camera were calibrated correctly before the impact. So it's something we can't make that assumption. So if we're going to return the vehicle back to the road, we really need to understand that whole front detection system, incorporating all the modules, has been calibrated correctly. So that's probably something definitely worth keeping in mind and understanding.
A little bit on top of that, so absolutely critical to calibrate that, because we identify actually aftermarket glass, and there is no documentation that you can access and see, like, is this okay or not. So if we investigating an accident, like, if, let's say that this vehicle was killed somebody, and we still have a glass that we can calibrate that glass. We technically can access system. We can do that in the next step. Maybe we'll see how we go with the question. And we can see the angles, pitch, yaw, and roll, and then we can try calibrate it. And then if we see that the gap in between the values that we are achieving and the values that was previously recorded in the system is big, then it's fair to assume that actually system was not calibrated, after that aftermarket glass replacement. So there will be one clue. Or if it's completely failed, then we know, okay, system was definitely contributing to the accident, and then it's question how much.
For sure.
Yes.
So yeah, also around the aftermarket glass. So I'd like to sort of just try and demonstrate the difference between an OEM glass versus an aftermarket glass, and what difference it does make, or what difference it potentially could make, because I'm sure some people would assume that glass is glass, and then we're just mounting a camera in the right place, but really just to show the influence it can have if it's an aftermarket versus OEM, and what the smallest difference could make. So I think you might have a slide there for that, Igor, if you got that available.
Yeah, there was a question which came which came earlier, so we can share the material which we prepared for that. Unfortunately, slide was not completely done by our standards, but it still will be good, and it will be very relative to what we talking here also. So let's wait a little bit until we get the bigger screen. I'll try to zoom in. So these are ADAS Made Easy tech talks, which we're sharing with the industry, with the selected stakeholders to understand better So the question came, how can aftermarket windscreen then affect that ADAS system? And if we're looking at here on our previous slide, when we're demonstrating that, technically sensor is positioned in a 3D world, and there is much more into that, like, we'll see if there will be interest to go deeper into that. So that sensor really need to be like, calibrated properly. And there is a nice study from the Institute, Insurance Institute for Highway Safety, what's the actually influence of aftermarket glass. And just shortly here, picture, I'll zoom it in. You can see that this plastical attachment, which is on aftermarket glass, it's actually a bit slack loose, and the module inside can actually move from 0.4 to the 0.6 degree on the other side. So technically 1 degree, like, off just in the housing itself, and which is significant. And this is the case from USA, but I'll share here, something which we have, which is ongoing, which is happening with, I think we have actually, maybe even with us, our auxiliary partners, like, and this is from the Ford Transit. What you can see on these two photos, one, it's like, aftermarket glass. I'll try to zoom it a little bit more. One, it's aftermarket, and this is fitted already. We can see the camera here in that window. And then we can see, like, on the right side, the OEM glass. First thing that you will notice is that small lines. These are heater wires there. And if you compare and measure this distance, actually will be quite the same. What we can see very fast is that aftermarket glass have a bigger kind of angle, bigger hole, bigger field of view here, opening bigger field of view than this OEM, which is probably better. But what we see here on these pictures, and the left picture is actually not that great. I'll just a second. I'll try to. Something happened with my slide. So I hope you can see it here. There is a difference in the thickness of the glass. Usually aftermarket glass is a bit thinner, and aftermarket OEM glass was having 5.4 mil. Measurement here, it's not perfect. Actually, the glass, it's thinner than that, but it's showing 5.1. And why this now become important? Because if we're looking this slide here, we have something which is called refraction. So technically, I'll try to make it better for you guys that you can see it.
That's good.
So the light is coming. Let's say the light is coming from the right side, and that's our angle of the glass. And then it will have refraction through the glass, and then we'll finish somewhere on the other side. And then on this side, we absolutely will have, like, that lens and that CCD sensors, like, for example. And if we have problems with the thickness, like, then that definitely will cause the potential problem there. So we're investigating this. We'll put the OEM glass. One vehicle it's Motueka, one it's in a Queenstown, and we will actually be able to confirm where was the reason for the failure of the autonomous emergency braking. One thing just shortly on this, what we can point to the current legislation in New Zealand, and that will be interest of government, probably bodies, and also the windscreen repairers. When we have, like, when we have any chip in this area here, so like, small chip, like, that will definitely change the way, because of that refraction, where that, light it's landing on a chip side, and, the whole other processes internally, especially segmentation, I wouldn't go in depth on that, can actually be, like, calculated wrongly. So the changes needed to heal this, the solution for this challenge is to introduce maybe better legislation which will address, like, these small chips, like, not just 15 mil, like, something which is actually, in terms of sizing on camera, it's big as house. So I think I, pointed quite well on that windscreen thing, just shortly, because we have that obstacle, and I have something which was added on last minute. That's the truck. So what's wrong with this picture? That net which I was just talking about, that net was internal. Yeah. But on this one, what we have here, Tony?
Oh, the stone guard's external.
And so this is the camera here, isn't it? Yeah. And so I have a slide here from the report, which was done with one of our electrician, where we educating actually some of the electrician guys around, and that was just done a few days ago. And what you can see here it says advanced driver system, collision warning with emergency braking. So the vehicle have emergency braking. It's 2019. Input signal failure, of course, and then reason here, it says component or system operation obstructed or blocked. So definitely truck wouldn't work or would, I would say, poorly perform in autonomous emergency braking,
and that definitely goes to show the importance of making sure aftermarket accessories are fitted correctly or in accordance with maybe OEM procedures. And it's a pretty good or bad, if you look at it that way, example.
The truck was, by the way, the story of the truck, it's the client is not focused at the moment on that problem. They have a bigger problem. Truck was sold, and it's a very low mileage. So they're really struggling now to get the truck, in kind of operational condition. I don't think, that they will be their priority to actually look at more into this thing. How will be the question, Jason? Are we have something?
Quiet audience this afternoon. Anybody out there got any questions they do want answered? Something we haven't covered, something that you sort of came to hope to hear more about that we haven't covered? Please jump on and just let us know. We can certainly pivot towards something like that.
Is there any appetite there in the audience, guys, to see maybe something live, go in camera system, see this angle, and maybe point few more stuff there? Or please engage with us. And
just got a question here from Eswin. Does aftermarket glass use OEM specs but own measurements, which we need to recheck? It's a hard one. So the question is sort of Ashwin's getting at is how can they know that the glass is going to be OEM spec? Or the only way to find out is to go back for a calibration. And I think that is probably the only way. So there's obviously going to be a tolerance that the camera can work within, and inside that tolerance, it's going to calibrate. It's going to effectively, for lack of a better term, reset that 0 point, and that will work adequately and safely. And then obviously it gets outside that tolerance where we can't calibrate it, and the pitch angle's incorrect, or something in that glass is causing a different refraction than what the camera module would expect to see, and we cannot calibrate it to the OEM target. So good question. There is no real easy way to tell before you install it. And anything else on that, Igor and Tony?
Well, I'm thinking at the moment, because the question was on the glass side, I will share again screen. I was just use the opportunity to dial into the camera system on this vehicle, and let's see what we can see on the parameter side. So what we have here is three values: pitch, raw, and yaw, 1.20 and -0.5. This value will, like I said, will change. If we go into these settings, and if we perform camera calibration here, so we can investigate. And of course, if they are out of range for that system, depending from the system to system, then calibration should fail. Unfortunately, there are a few cases where they're changing kind of principles, I would say, and when the calibration fail, the producers still keep the previous result, but only a few of these I was fine, so I don't know what's the reason for that. We need to investigate. I assume, that if the technician press the button for calibration and calibration fail, they don't want to kind of introduce the fault in a vehicle if they don't have the equipment or something like that along these lines. Very hard, very concerning case, but we really wouldn't share at the moment, because, we really need to dive in.
Yeah. So Todd's just made a comment. Thank you, Todd. The truck's a great example of why we need to ensure our warrant of fitness and certificate of fitness system is up to date for modern vehicles. And he said that this project is slowly gaining momentum as an action of Road to Zero. And 100%, Todd, we're fully behind you with that, and that's something we talk about for a long time. Obviously, it's not just trucks with stone guards. There's a multitude of vehicle modifications and that probably do make the system not operate as the manufacturer intended. So it's not just about the calibrations being performed correctly in the correct space and with the right equipment, but it's also vehicles that are being presented that haven't been modified or have got systems operating as they should. So very, very good point. And he's just also asked another question. Is there still an issue with manufacturers not providing OEM calibration specifications? And without a doubt, Todd, that is a daily challenge, is gaining that access to OEM information. And I still believe it's across the board. It's not just in our calibration world. It's access to information for repair information. I think some panel repairers struggle to get information, especially around the technical stuff. I think there's good programs for them on repair, like structural repair, but certainly the electronic components and the later systems are certainly lagging behind with that access to information. But yeah, boys, you want to elaborate on that too?
I think you've covered it off. I mean, at the end of the day, the collision repair industry has suffered. It's suffering in a number of ways at the moment, and I would say a lot of it is due to the lack of awareness. I mean, there's a lot of guys out there currently that they just don't know what they don't know, and we really need to start looking into how can we proactively give the information out so these procedures can be done correctly. And one of the biggest drawbacks that we have at the moment is the availability of that data. So
yeah, for sure.
Correctly.
And definitely, I think that's we see our place in the industry is as much as doing the calibrations and providing proper process and procedures around that is also education. Like, it's a massive thing that the industry needs to be upskilled or needs to be aware a bit more of these systems. And a great question there from Ash. He's just asked, if a bumper is removed for repairs, would the system need recalibration? And the answer is 100% yes. And if you go into OEM manuals, which obviously like Todd's just brought up, if you went through the OEM procedure for removing a bumper and refitting it, as part of that procedure is then performing the calibration, because you've moved the space that the radar is looking through, or that so 100% that would need calibration. And that just points to me, obviously, awareness across the board is very, very low about these systems, and access to information is a struggle. Todd's just mentioned that it might be worth a discussion with Repair Cert NZ if we're not already in discussion. So yeah, we'd happily talk about that some more, Todd, for sure. Yeah, we'll be in touch on that one.
Maybe a little bit more on that side, like, on the bumper. So not just when you drop the bumper and put it back, you need to calibrate. You actually, if you paint, like, bumper, you actually need to recalibrate. And on just a little bit teaser for the next 26th, next Thursday online presentation, we will actually deal with that, and we will show, like, influence of the thickness of the paint on that radar beam. Hopefully we will get the vehicle, like, on time, and we will be able to demonstrate that. There will be a few different demonstrations live, how the space influence, like, the angle, how the angle change, like, when the space is actually clogged with something simple, like, the garbage, bin and something like that. So there will be good stuff. And if you guys want to follow up on that next one, that will be awesome. Maybe just shortly, I know I always talk too much, sorry guys. But one thing I think it's important that if we want to, and government just put that new document out regarding the future level 4 and 5. If I believe personally, if we want to get that confidence of the public to accept the autonomous high-level automated vehicles, then we need to address properly, like, level 2 plus, level 1, like, and I think it's important before we go and prepare to dive deep, that we just take a little bit of snorkeling, like, before,
I think there's a common term used that's walk before you can run, I think would be a good term we could use for that. And you're right, the industry is behind the 8 ball, I think, on that one. But the only way is forward, and we need to obviously band together and work on that. James has got a little question or a statement here, that you'd like to think that any parts sold must meet OEM specs in relation to any parts critical in an ADAS system, e.g. windscreen must meet an OEM spec number. And you would like to think that, James. It's a very, very good point, and we certainly do not disagree with you at all.
It's not only windscreens, it's aftermarket bumpers. Because of the composition of the plastics, they have a different reflection of the beam going through. It's the same with them behind the emblem. You can have an aftermarket replacement cover for that emblem, and it will dramatically change the performance or the outcome of what that radar is trying to achieve.
Yeah, and I think that's a good point, Tony, about the we mentioned earlier about the paint thickness. Putting a vinyl wrap on when you've sign written a vehicle across where a blind spot radar may go, and the influence that has. Like you say, an aftermarket bumper that might have a slightly thicker material across the surface of where the radars are. There's so many things that just could be influencing the operation of the system. And Todd's just asked, is there a most common type of fault we're finding when calibrating vehicles currently? And I think the most common one probably would be aftermarket glass. We do have problems getting calibrations. I wouldn't say it's super common, but definitely not a do get aftermarket glass. 9 times out of 10 we get a calibration perfectly. But that's where we see the variances. The only other things we're finding is repairers of repaired vehicles and adjustments that needed to be made to radars when they've obviously put back in the space. We calibrate it, can't achieve a calibration. We need to make an adjustment before the calibration is successful. Anything else, Tony and Igor, to add to that one?
Well, I agree on that aftermarket glass, like, on the windscreen side, like, there is not much challenges there. I mean, typically will be that, and they will need to rectify, you just need the OEM glass. On the radar side, yes, there are much more, things in which influencing the process, like, from the thickness. So, you need to measure the thickness, see how you in that OEMs, and then biggest challenge so far is that for us, like, when we want to confirm the module need the replacement, we have a very interesting, actually, exactly the car like this in a Whangarei. I think 10 days ago, the intermittent fault to the 2 years, we're trying to match the reason for the fault to be that original, collision impact 2 years ago. And then, performance failed over that period of time. When we failed the calibration, and at the end, we was make a call that we need to replace the module. And module was very expensive. It was fitted like, with a second hand for the testing, second hand module. It's fitted in, recalibrated. And now we have a whole lot of new question which opens, who holds the liability when you put a second hand part and all sorts of stuff. But the challenge is because that radar beam, it's invisible. Like, we cannot see it in a space here where it is, and how strong is on this side, how strong is on that side. So there is particular equipment for our group. Like, we did a little bit of research. Bad news is we need $157,000 for one particular unit, which we will maybe use 40-50 times a year. And as you can imagine, if you're an insurance company, like, you probably wonder yourself how much that will cost, like, if you perform that kind of, diagnostics. But on the other side, you really want to be sure as a repair, as a experts in the field, that when we said, radar need a replacement, that, that really, you don't throw $5,000 more or three, just, down the wind, and actually was the thickness of the paint, So we go back on that. So, well,
yeah. And I think too, obviously, probably not the most common type of fault, but certainly some of the most challenging faults is where there's underlying conditions, or there's obviously all these modules work together and communicate together, and sometimes you can have a problem present as something, but there's other influences that are causing that to be sort of put to the fore of a problem. So there's a lot of challenges and complexities around when there's exactly that you don't get an easy calibration. It doesn't just calibrate off the bat. Then it becomes quite complex to get a result sometimes, or to find the actual culprit for causing the problem.
To me, you've touched on something which, we're in the business of trying to reduce liability, and what we're trying to do here is do things correctly within the right environment, so we can guarantee the standard of the calibration that's being performed, because currently it's left open. There is no kind of guidelines in surrounding how this can actually be approached, and there's a lack of information for the guys to be able to sometimes do them exactly as it was through the OEM. Some of the guys, unfortunately, are using systems which are leaving not only their client open, but themselves open. And, there needs to be a lot more recognition, I think, for the industry of ADAS as to how people recognise how important it is to get this done correctly.
Just
a little bit more on top of that, he said something very important, like, that it's done in a correct space. So if you're calibrating blind spot, we really have that, big space which needs to be completely open. So if you fail calibration, first thing that you want to have in your mind as a technician, because I'm a technical trainer, I'm looking from that angle now, you want to be sure that because you need to go with the method of elimination. Like, if you don't know, if you cannot 100% confirm what it is, then you need to go with the method of elimination, which means tire pressure, good. Standard suspension, good. Space, compliant, good. Nothing in. All right. So, and then you move like, on your equipment that you're using, compliant. Target, size, radar cross section, all of that, like, latest version of the software, like, proper module, and all of that. So then we know, and that was the case in Whangarei. So we rule everything else out, and then we said, okay, well, we need to say it's a radar. And you try to have that and narrow down on under 5%, because then it's acceptable from the position, like, of economical position, because, you can actually put that, you can put that in your cost, like, but you cannot lose the money, like, and you don't want to make the damage and additional cost for your insurance partner. So that's
yeah. And I think just on from that, obviously next week, next Tuesday, we're going to have another one of these sessions. So we'll certainly send an invite out to you all. But what we propose to do there is actually just really show the influence of not having the correct space or having objects in the space, and obviously we'll perform a read and a reread with something in the space and show you just how different the readings can be. Because what we can also achieve, and it's quite a scary thing, is you can get what we term as a false positive. So you can get a calibration achieved because it's in the window of where it's looking, but it could be well outside what you would call accurate. And then that leads to problems. Obviously, some of these systems, I think we might have mentioned previously that a front radar is looking 300 meters down the road, and as little as a couple of degrees, 300 meters down the road, I'm sure you can do in your own heads how far out that might be and where it might be not quite looking in the right place.
So you had a case recently where you'd performed a calibration on a vehicle and it had been out, was it for 2 weeks? Was it before?
Yeah, actually, very good point. It was so it was on a good memory. Toyota Aqua. So just a windscreen replacement, calibration done. Nothing abnormal. Came back 2 weeks later with a fault on the dash, saying just a camera braking fault, autonomous emergency and forward vision camera fault code. Looked into it. Fault codes, recalibrated it, re-road tested. Fault didn't represent for 2 or 3 Ks. What it ended up being, so long story short, something as simple as they'd put their dash cam, so a forward-facing dash camera, on the windscreen, and it was the silicon from the suction cup would have been millimeter overlap, where obviously the camera's field of view could just see it, like the smallest amount. Something that probably could have been quite easily overlooked. Like, it was just lucky that I think I've seen it. I don't know whether not luck, I suppose, but it was just something identified. And man, that's something as simple as that, where it still went for 2 weeks after they'd picked the vehicle up and from the collision repairer, where they'd stuck their thing back on. And that's obviously influencing the field of vision or influencing the decisions made. So yeah, it's scary. Todd's just quickly mentioned here, secondhand parts issue is very interesting. How common is it for repairers to use secondhand sensors and potentially radars? And I think now more and more, I believe it's probably not so much of a problem. But then we run into issues around module coding and variant coding and being able to put the software to suit that vehicle. Tony, again, from the industry, might be able to give us more insight on that.
It depends, in my opinion. I personally will go new. There are some repairers, because they focus on key-to-key time and not actually on the safety or the performance of that module, it suits them to achieve their outcome where it's spinning out and out the door. And as we've done in previous demonstrations, if you actually look at the back of the module, it says if dropped, replace. How can you guarantee that during its previous life or being removed off of the original vehicle that it hasn't been compromised? And I personally don't take that risk. I'm risk averse to those. I mean, how many people go out and buy a second-hand computer, given the fact that they don't really know how it's going to perform? And if that means that, it's not doing its job in the respect of it can have horrific outcomes, I don't see it.
Yeah, and that's a pretty good point about the degradation of electronics, and I think we mentioned it in our little explainer videos that we are driving mobile computers. They're very, very electronically.
And as you pointed to just then, these electronics do deteriorate on their own. So if you're buying a second-hand part that's the same age as the one before, you can have silicon bleeding inside the module itself. You don't know that life of that component whatsoever. So
silicon chip bleeding, not the silicon, not the silicon, it's silicon. So silicon chip bleeding, which is term in electronics. Yeah, great point.
Yeah. So just conscious of time, gentlemen, it's 2 minutes to 2:30. So that's been a really, really good session and great engagement. So thank you very much to everyone that's joined. It's been good to try and answer some of those questions. And hopefully we've answered them well. But like I say, we're going to hold another session next Thursday, same time next 1:30, 2 o'clock, I think, next Thursday. So we'll firm that up and get that out to you. And please come at us with questions and things you want answered and myths you want dispelled or maybe even proven. Because we're more than happy to try and, again, it's around awareness and education, and that's a big thing for us. So there is one last unanswered question that maybe we can quickly jump on for Irene about the average cost of calibration, and that's a contentious question, and it is a little bit hard to answer, but I'm sure Igor's got a fantastic answer for that.
Love the space. I mean, it's a beautiful floor. It's greened, because for us it's important. Lighting conditions are perfect. A lot of investment here. ADAS expert, it's premium, unfortunately, and I hope we will stay premium. With the numbers, absolutely, if they'll be recognized, and when the numbers start to go in, then absolutely price will represent that. If we have a few calibration, when we really adhering to these strict things, then you must accept that you. I mean, we will be happy to see that insurance partners recognizing this and supporting this, because we believe that's the way to go.
Yeah, and I think a good probably way for us to put that is there's not a cheap calibration. It's expensive machinery or equipment. It's the training and the upskilling to become a qualified technician, if you like, and to do them well and to do them accurately is very time consuming. And there's also the space and some requirements. Though our minimum space required is around 15 meters by 12 meters of a bay where we do these calibrations. So you can appreciate the cost of real estate these days, and the space is a big requirement. So, hey, it's 2:30. I'm just going to really quickly get Gary's just ask a quick one on thoughts of mobile calibration on windscreens. Workspace is not always ideal. And again, Gary, you're very right. And it's to do with if we're going by the OEM procedure and the space requirements, and also we know that the influence of external lighting and conditions.
Level of the floor is a big component into getting a quality.
Yeah, so I think that answers that. The environment is just not controlled. We wouldn't endorse it. We wouldn't support it. In our network is we can't control that. So yeah, hopefully that answers that question for you. But thank you all very much for joining us today. I hope you've taken something from it. I hope everyone's had a good afternoon, and I'm pleased that the rain in Blenheim sounds like it stopped, so that didn't impact it, because it got pretty heavy there. So we got through. So appreciate you guys for coming back on from this morning, and thank you for sticking with us. And like I say, we'll be in touch around the next one during this week. So thank you very much, guys. I appreciate your time, and girls, obviously, and we'll talk again soon.
Thank you, everyone.
Thank you, everybody.
Thank you.
See ya.
See ya.